open your books to page 355. We are starting in activity 24, and it's called adding and subtracting polynomials. So lesson 24.1 is all about the terminology. So we're going to have a lot of vocab, which is why I posted a note sheet. So the first learning target is identify parts of a polynomial and identify the degree of a polynomial. A solar panel is a device that collects and converts solar energy into electricity or heat. The solar panel consists of interconnected solar cells. The panels can have differing numbers of solar cells and can come in square or rectangular shapes. So some of you might have seen solar panels in real life. We have one pictured below, and I want you to count up how many solar cells are in the panel. So there's 4. Keep going. So this is a 4x4. So there's a total of 16 solar cells. If a solar panel has 4 rows, as the picture does, but could be extended to have an unknown number of columns, x, write an expression. An expression has no equal sign to give the number of solar cells that could be in the panel. So I'm going to start with the 4 because that's the number of rows. And I would multiply that by the number of columns, which we don't know how many columns there are, so we're going to use x. 4 times x is written as 4x. Okay, so 4 rows times x columns. Number 3, write an expression. Again, an expression has no equal sign. That would give the total number of cells in the panel that has x rows and x columns. So if I go back up, okay, in order to get 16 earlier, I did 4 times 4. Okay, well, if we have x rows and x columns, instead of this being a 4, it would be x, an unknown number. Same thing over here. Our rows and columns are both x's, so to find the total, it would be x times x. Now, think about our exponent rules. Keep the base, add the exponent. So it's x squared. Number 4, if there were 5 panels like those found in question 3, write an expression to represent the total number of cells. So it would be 5 times x squared, which is 5x squared. All of the answers from questions 1 through 4 are called terms. So a term, you've been using terms all along, you just didn't know the name of it. So a term is a number, a variable, or the product of a number and or variables. Okay, so number 5 says write an expression to represent the sum of our answers from questions 1, 2, and 4. So question 1, the answer was 16. This is considered a term because it's a number. And then sum, we're going to add the answer to question 2, which is 4x. And 4x is also a term, plus 5x squared, which is also a term. So we are going to add the word term to our note sheet. It's called a VIP, which is a very important paper, so don't lose it. You can write this down on the graphic organizer in Schoology, or you can write it down just in a piece of paper. A term is a number, variable, or the product of a number and or variables. So for example, 5, that's a number, it's called a term. Negative 1.75, that's a number, it's also called a term. X squared, 3y, z to the 8th, w, those are all terms. Okay. Expressions like the answer to question 5 are called polynomials. This is another vocab term that we're going to add. A polynomial is a single term or the sum of 2 or more terms, and they have to have whole number powers or whole number exponents. Okay? So, question 6 says list the terms of the polynomial that we wrote in question 5. So 16 is a term. Then we had 4x, which is a term. And we had 5x squared. Because I'm listing them, I'm going to separate them by commas. Okay. So we are going to add polynomial, or polynomial, some people say, to our sheet, which is a single term or the sum of 2 or more terms with whole number exponents. So I could have 10 A, B, C, and then I'm going to put 5 as the exponent, and that works because it's a whole number and it's not negative. So that was one single term. It says it could be the sum of 2 terms, so 2x plus 3, or it could be more than that. So x squared plus 7x plus 6. I could also give you an example with 4 terms, 5 terms, etc. All right, a coefficient. Question 7 says, what are the coefficients of the polynomial from question 5, and what is the constant term? So if we look at the math term box, they tell us that a coefficient, and I've used this term before, it's the numeric factor of a term, or I say it's the number in front of the variable. A constant term is a term that contains only a number. Just like our very first answer from this lesson, it was 16. Okay, so a constant term is just a number by itself, no variables. So if I'm looking at question 7, we're going to use our answers to question 6. So I'm looking at the coefficients first. A number in front of a variable. So 4 and 5. Those are my coefficients here. My constant term is a number by itself without variables. So that is 16 in this case. So let's add these to our note sheet as well. Coefficient. Underneath it, just as a reminder, I wrote a number in front of a variable. The definition from the book, numeric factor of a term. So I'm going to list 2x cubed, negative 5m squared, and 4y. So what I want you to do is I want you to circle, underline, box in, highlight, whatever you want to do, what your coefficients are for these three examples. So 2, negative 5, and 4 should be your answers here. The constant term is always at the end in standard form. We don't know what standard form is yet, but we're going to learn it later in this lesson. And the definition from the book, a term that contains only a number. So let's do some examples for this one. Negative 3, 8, negative 5.2, 11. Those are all numbers without variables. A number by itself. So what I want you to do is in your book, this is still on page 356, I want you to answer question 8. It says, tell whether the expression is a polynomial. Now there's two rules here, two deciding factors. The first one, remember from activity 19, we cannot have negative exponents. And we learned today that a polynomial has to have a whole number exponent, so no fractions. So 8a, no. And to explain my reasoning, I'm going to circle the negative 2 because we cannot have a negative exponent. Letter B, yes, this one's good. C, that one works. D would be no, and I'm going to circle the exponent of 1/2. That does not work. So question 9, for the expressions in question 8 that are polynomials, so there are two of them, B and C, what we need to do is identify the terms, the coefficients, and the constant terms. Okay, so under number 9, and you can do this in the My Notes section of your book. So 8b, I want you to list the terms, the coefficients, and the constant term. And same thing for question C. Use your notes to help you. Take the time to do this in the My Notes section of your book. Remember, always pause the video if you need to. So for letter B, there's two terms. The first one is 6x, and the next one is 4x squared. So the coefficients here would be 6 and 4. And then my constant term, this question is not applicable because I do not have a number without a variable. There's no number by itself. So we have no constant term for question B. For letter C, terms, there's just one, it's 15. I don't have any coefficients because there's not a number in front of a variable here. And then my constant term is 15 because it's a number by itself without a variable. All right. Number 10, another vocab term. So the degree of a term is the sum of the exponents of the variables contained in the term. So for example, if I had 3x to the 5th power, the degree here would be 5. Okay, because 5 is the exponent. Now, if I had something like w squared y to the 4th power, my degree here, we have to add the exponents. So it'd be 2 plus 4, which equals 6. So the degree here would be 6. Okay, so in this table below, we are looking at this long polynomial here. And what we are going to do is identify the degree and the coefficient of each term in this polynomial. So the first one is done for us. My exponent is 5, so my degree is 5. And you can fill in the coefficient. The number out in front is 4. The next one, my degree is the exponent, so it would be 3. X squared, my exponent is 2, so my degree is 2. And what's the number out in front? If it's not there, we assume it's 1. This last one here, remember if we don't have an exponent, we assume it's 1, so my degree is 1. And the number out in front is -1. So this is called the degree of a term. Okay, so on the back side of your note sheet, we're going to fill this in. The definition from the book, the sum of the exponents of the variables contained in a term. So when you're done filling in that definition, I want you to fill in the examples table. So you're given a term and I want you to write the degree. Don't forget, if there isn't an exponent, we always assume it's 1. So my degree for this first one is 1. Then I have 1 plus 1, which is 2. 4 plus 2, which is 6. What about this last one? Do I have a variable? No, so I don't have an exponent on a variable, so this would be 0. All right, let's do question 11. For this polynomial, and it's a really long one, how many total terms are there here? 6 terms. Okay, we need to list each term, identify the degree of the term and the coefficient, and then we're going to identify our constant term. So you should have enough room under question 11. If not, use the My Notes section of your book, and I want you to list them vertically, just like I do. So we have 2x cubed y, that's my first term, and pay attention to the signs. The next one is a negative. The next one is positive 9xy. Even though these are in 2 separate lines, don't forget there's a negative in front of this 13y to the 5th power. Positive 5x and a positive 15. So what I want you to do is take the time to write the degree and the coefficient for each of these. And then don't forget to identify the constant term. So we have 3 plus 1, which gives us 4. The coefficient is 2. If you didn't try this already on your own, make sure you pause and take the time to fill this out. 2 plus 2 is 4. Coefficient is negative 6. 1 plus 1 is 2. So my degree is 2. My coefficient is 9. Degree is 5. Coefficient is negative 13. Degree is 1. Coefficient is 5. And then the last one here, I'm actually going to erase this because my degree is 0. My coefficient doesn't exist. What do we call 15? This is our constant term because it's just a number without a variable. All right, this is where we are going to stop today. Make sure you have everything filled in your book and on your note sheet. Do not lose the note sheet or wherever you wrote it down. We're going to use that in the next class.